Here's an example. We've got it formulated like this, okay? What are these things here? This is a what? It's a constraint, okay? If you didn't know any decision math language, what else could you call this here? Inequality, okay. What we do in this method, we change it so it's not an inequality. So I'm going to label that one number 1 and that one number 2. Number 1, we change from an inequality into an equality. But we don't just write 3x plus 3y, and I'm deliberately leaving a gap here, equals 120. Because 3x plus 3y could be less than 320. So if it's going to be equal to 320, I'm going to add something else to it. And I add in what's called a slack variable. And for your first slack variable, you usually use the letter S. So basically, if you add something else onto it, then it will be 120. And that thing there, the S, is a slack variable. Have you heard the expression that somebody's taking up the slack? It's literally how much sort of play there is in a system, how much spare capacity. And it's linked with that. It's taking up any spare capacity, any excess. So, the first constraint we rewrite like that as an equality. The second one we will also change into an equality. So instead of being 2x plus 4y, and we'll have the 150 over here, what do you think will go in that space? Let's have a guess.
S.
Not going to be S, because that would mean it'd be the same amount as here, and we don't know it's the same amount.
S down.
Just think alphabet. After S?
T.
T. Okay, yeah. Okay, we just use T for the next one. So here, that T is another slack variable. Okay? So the first thing we've done then is we have changed from 2 inequalities into 2 equalities. Okay? Right, the next thing that we do is we start to rewrite our problem, and we look next at our objective function. Our objective function at the start was this thing here, maximise z, which is 10x plus 12y. Z equals 10x plus 12y. So we're going to change our objective function, because our objective function also needs to include S and T. So we put an S and we put a T in there, but we multiply them by 0. And it seems a bit silly, but that's what we do, and you'll see why in a minute. Okay? And you don't really have to understand why, you just have to be able to do it for the time being. Because our constraints now are in terms of x, y and s and t, our decision variables now also in terms of x, y, s and t. So we add no s's, we add no t's. But then each constraint and the objective function have all got in them x, y and s and t. Then what we do, we always rewrite this line here, we always rewrite it so it equals 0. And we always do that by shifting all of this onto the other side of the equation, the equal sign. So, I keep the z where it is, but all of these things I shift to the left. So I'll have a minus 10x, a minus 12y, a minus 0s, and a minus 0t. And then what I do is I write it in a tabular form. So I'm going to write that now in a tabular form, and you do it like this. You have a Z column on the left, an X column, a Y column, an S column, a T column. That's every letter we've come across so far. We have a value column, and then we have space at the end to make any notes. The top row, underneath that heading row, the top row always corresponds to our objective function. How many z's do you see there, Will Taylor?
1.
Let's write that there. Sam, how many x's do you see here?
-10.
We'll put that there. What do you think the next number in this table is? Anybody? Yeah. -12. Yep. How many s's are here?
What's that saying next to the column that we're doing at the moment?
Here.
No, like what's the name of the row that we're doing?
I'll just label that. It's for the objective function. Okay. It's just we're using these numbers here from the objective function to go in here. So it's always a z, one z. It was -10 there, -10 there. How many s's are here? 0. How many t's are in that row? How many t's? Anybody? I don't mind. 0. Okay. And the value is always 0 at this point. So at this point here, this is always 0. So we've put one of our objective functions in, well, our one and only objective function in. The next thing we do is put our constraints in, but then they're equality form. So if we look at the top of the board, there is our first equality. How many z's can you see in that? None. How many x's are there in that? How many x's are there? 3. Y's?
3.
S's? 1. T's? No. Okay. And what's the other number that is there in that one we haven't dealt with yet? 120. That one goes over there. So that was going from that constraint written down as an equality. What do you think, how do you think we're going to write this one down? How is that one going to appear in this row? Just follow the pattern we've just done.
0, 2, 4, 0, 1.
That's exactly right, yeah, okay. There were no z's, there were 2 x's, 4 y's, no s's in this one, but there was a t and we had 150. And when you have it like that, in that state, that is called your initial. Now for some reason we don't use the word table, we call them tableaus. Everybody just calls them tableaus. So that is the initial tableau. And if I can remember whether tableau has an x on the end, I could actually label it properly. Does tableau have an x on the end?
It probably does.
So singular doesn't. Then we'll leave it like that, okay? All your initial tableaus, the top row will always be linked to the objective function, the second row to your second constraint, the next row to your third constraint. If you had another constraint, you'd have another row. What would have happened if I'd had 3 constraints? As well as having another row, what else would I have had to have had? Another slack variable, yeah. I'd have had to introduce u. For that third constraint would have had to have a slack variable, that's right, okay? The columns which have just got 0s and 1, 1 in them, they have a special name. Okay? So can we write down that the columns with all 0s and 1, 1 are called basic columns, or sometimes they're called basic variables. Basic, well, they're called basic columns, the columns itself. And what you do, you find those columns and it actually tells you what the answer is at this point. It tells us at the moment what our solution is. It's not an optimal solution, but this is how you do it. So I'll just wait for people to stop writing. You start, well, ignore the Z one for time being. Where's the first column apart from that one with 0s and 1s in? S. Okay, this one here. That means, at the moment, if we manufacture 1 unit of S, and then there's another column here, and if we manufacture 1 unit of T, our profit, which is what Z is, our profit will be 0. which is always how you actually start. You make nothing. Initially, you're making nothing, except these slack ones over here. You always have your zeros and ones in your S, T, and U if you need it column. And the way to read it is, you find your zeros and ones, and if you make one of those, and if you make one of those, your profit, which is always what Z is, will be 0. It's not very helpful at the moment, but when we come and do something else in a minute, we will end up with a different version of the tableau, and that is still how we read it. Okay? Actually, what I said at the moment, we make 1 of S, that's not quite right. We don't make 1 of S, we actually make 120 of S. You ought to go over here. We make 120 of S, we make 150 of T, and our profit is 0. Okay? It all sounds very strange to start with, I realise that. We'll go on, hopefully it'll make a bit more sense, but you need to go on for it to make any more sense. Right, we need to know, how would we know when we've finished with a tableau, when it's optimal? So, we need to write down an optimality condition, and then this is something you need to learn. So, can we write down an optimality condition? Because we're going to do something to the table to change it, and every time we change it, we need to look back and say, is it optimal? And this is it. If the objective row of a tableau has 0 entries, that doesn't mean no entries, it means there are zeros in there, 0 entries in the basic columns. Now at the moment, does our objective row have 0 entries in the basic columns? Because the basic columns are these two, and it does have 0 entries in the objective row. But then there's and something else has to happen, and no negative entries in the non-basic columns. Then that means you have an optimal solution. We said we have at the moment 0 entries in the basic columns. The basic columns are the ones with zeros and ones in. It's the here and here, the S and the T. But do we also have no negative entries in the non-basic columns of the objective row? No, we don't. So at the moment, that -10 and that -12 mean at the moment we are not optimal. So we can just say, in our existing tableau, the -10 and -12 in the objective row mean we are not optimal.
Oh, it's just the negative in the objective.
Yes, it's just the objective row, ones you look at for the non-basic ones. And if you're not optimal at the moment, that means you need to create a new tableau. And what we're going to do now is run through the steps of how you make a new tableau, a new table. Are we going okay, or am I going a bit too fast at the moment? Okay? Right. Table. Step 1 is you find the most negative entry, in the objective row. So in our objective row, you've got it written down still. What is the most negative entry at the moment? The minus 12. Yeah, that one there. Okay. So we are dealing with the Y column. So in our example, that means we're dealing with the Y column because of the minus 12 that was in it. You call that column the pivotal column. So you call that column the pivotal column. Step 2, the second step, is you calculate what are called theta values. And to get the theta values, a theta value equals the value number at the end of the row divided by the value in the pivotal column. The value in the pivotal column. But you only do it for if this thing here is a positive number. But you only do it for positive values. So, if you all managed to get that written down.
What is it, the value of what?
Calculate.
It's the value number, which is, in other words, what is over here, the value number, divided by the value in the pivotal column. Now, our pivotal column we identified as being this column here. Now, what you actually do is you usually arrow your pivotal column. Okay? So what we are going to do, we're going to do the number in this column divided by the number in this column, as long as the number in this column is not negative. And they will give us our theta values. And you write your theta values usually over here on the right.
It is negative.
Here, this one will be negative for the top row, so we don't do it. For the second row, we will be doing that number divided by that number, and that will not be negative. So for the second row, we do work out a theta value. It'll be 120, which is what's in the value column, divided by the value in our pivotal column, which is 3.
So if it is negative, just don't do one.
If it's negative, you just don't do one, yeah. So theta value there is going to be 40. And for the row underneath, our theta value will be 150 divided by 4. What's 150 divided by 4? It is 37.5, yeah, or 37.5. I'm going to stick to fractions. 37.5. We okay with that? Okay. Back to our instructions. We've had step 1 and we've had step 2. What we need now is step 3. In step 3, we identify the minimum theta value. We identify the minimum theta value. So we, in our example a minute ago, had a theta value of 40 and we had a theta value of 37.5, which is our minimum one. Which is the smaller of those two? It really is easy. 37.5, yeah. Okay, that's the minimum one. You normally label and arrow it. So if I go back to my diagram, okay, that's the smallest one there, the 37.5. So you normally arrow that one and label that one the minimum. And that now has identified for you your pivotal row. So this now is we're going to refer to this one here as our pivotal row. So if we can write down now under here, this identifies the pivotal row. So we now have a pivotal column and we have a pivotal row. What do you think happens where they meet?
The answer.
Well, it's not the answer, it's the pivot. Okay? Where the pivotal row and where pivotal column meet, that is the pivot. So if you can write down where the pivotal row and the pivotal column meet, that is the pivot, and when we find our pivot we circle it. So, going back to our tableau, we had already identified here a pivotal column. We've identified here a pivotal row, so we circle that value, and that 4 is our pivot. Identified our pivot, what we need to do next is draw out an empty table. So what you need to do now is draw a table, put the same column headings in, and leave space at the end for our notes. And I also suggest you put horizontal lines in for each row. Sometimes it's actually easier to do a whole grid like this. Right, which position was our pivot in? Megan, can you describe in this table here, where was our pivot?
Like in what way? Where you put it?
Like, if I put my finger here, where was my pivot?
Down and then.
It was here, wasn't it?
Yeah.
Okay. You put a 1 in there. Okay. Yes, you've got to draw it out again, a blank one, and you've got to put a 1 in that position. Seth, have we done this? With a 1 in there? Do I believe you? No. Okay. So, draw that out. There's always a 1 in there. What used to be in there? 4. No. What we have done, and you always ask yourself, what used to be here? So, I'm going to sort of do some notes down here, okay? That used to be 4. It's now 1. What have you said, Adam? Yeah, to get from there to there, I divided by 4. I divide my entire row by 4. So whatever you divided by, what I do now, I divide the entire old row by 4.
How many marks was this question?
Quite a lot. Okay. Often in an exam, they will have done some of it for you and will ask you to do the next stage, stuff like that.
None of it's really difficult, it's just easy.
Yes, which is why I said on the board at the beginning, it's like an infuriating topic. It's not difficult, it's fiddly, and when we get into the numbers later on, you get all sorts of, when you're dividing, the numbers often get very messy in fractions and stuff, and it's very easy to make an arithmetic error.
And do one wrong.
You're stuffed. If you do one wrong, you can get stuffed, yeah. So, here, we're dividing by 4. Right, I'm going to see if I can put my two tableaus together. Well, there's the bottom row, you can see it on the top of the board. What is 0 divided by 4? What is 2 divided by 4? A half. What is 4 divided by 4? The 1. What is 0 divided by 4? What is 1 divided by 4? What is 150 divided by 4? Yeah. Okay? That is that new row. What did I say earlier on were the very important columns? The basic ones, that's right, Will, yeah. And how can we identify basic columns?
0 and 1.
They're all zeros and ones. This column here becomes a basic column in the next tableau. So the column the pivot is in becomes a basic column. What does that tell me about the other entries in that column? They must be 0. Okay. We're happy with that bit?
Why then?
Because that's what happens. The pivot always identifies where a basic column is moving to. And if it's a basic column, by definition, which is what that's said over here, is it's all noughts apart from a 1. Well, there's a 1. They have to be noughts. Now what you've got to do is think carefully. You look at your two tableaus. What used to be in this position I'm pointing to here? Seth, will you watch, please? What used to be in this position? Minus 12. Well, I've got to get a nought in there. You ask yourself, how many of this number here do you add or take to this number here to get that 0? I will say that. Yes, Megan's got it, okay? I will go through that again. Okay? How many of these do you add or take to this to get that? Megan? 12.
Will that always be 1?
Yes, that will always be 1. So what we do is this. Row 1 in this table is going to be the old row 1 plus 12 of our new row 3s. And what I'm going to do is I'm going to star the new ones. So my new row 1 is my old row 1 plus 12 of my new row 3s. Okay? So that star up there means a new row. If it's not starred, I mean an old row. So I'm just going to write that down here. I've just written down, I'm going to write down a bit bigger. R1 star equals R1 plus 12 R3 star. That's what I just written down. And the star means it's a row in my new table. If it's not starred, it means it's a row in my old table.
We're going to have to do another table because it's still going to be minus.
Oh yeah. You're quite right. Yes. Okay.
The question is only less than 12 marks. I'm just going to leave it.
We'll have a look later on to see how we're going. I'm wondering whether we get this example finished before half term, but we'll see how we go. Let's have a look. So, right, I'm going to pick on different people to do sums. Right, I'm going to pick Adam first here. In here, it is my old row 1 number plus 12 of my new row 3 numbers. It'll be 1 plus 12 nothings.
Hang on, why are we using row 3?
It's always multiples of the row that appears in here first, Megan. Hang on. So, okay, Megan. The new row 1 is always the old row 1 plus some multiple of a row that we did first in the new tableau.
So it's not necessarily the third one?
No, it's the one that's first one that's in there. It's the one, it's always the one with the basic column with the 1 in that row. Right, I'm going to go to Seth to do the next one. Seth, the number that goes in here, Seth, will be my old row 1 number from that position plus 12 lots of that. So I'm doing minus 10 plus 12 lots of a half, which is minus 10 plus 6, which you said, Seth, was? Minus 4. Yes, you do it all the way across. Rob,
Yes.
this one here, I need to do 0 plus 12 lots of 0.
So 0.
I'm going to say 0.
Is correct.
Hang on, why is that 1 up there? Oh, because it used to have 1 in it.
Right, Jess, here, this new T column one, it'll be that number there plus 12 lots of that number there. What will it be?
0? It's 3.
3, yeah. It'll be 0 plus 12 quarters, that's right. Okay, next one, Will. This number here will be this one here, plus 12 lots of that. 450 is correct, well done.
You are quick misses.
Okay? Excellent, right. That was new row 1. We now need to do the same thing on our new row 2.
But why? Because we know the national table? Why don't we just start?
No, we finish this table first, because without this row in a minute, we can't do the theta values in a minute. So, our new row 2. You look first of all in your pivotal column. It used to be a 3. It's now a 0. How many of these have I added or taken to that to get that 0? Right, so Seth, you were correct in what you said. So my new row 2 is equal to my old row 2 and yes, minus 3 new row 3. So that I wrote down, yeah, my new row 2 is equal to my old row 2 minus 3 of my new row 3's. That's correct. Okay? Right, Sam, it's your turn. This position here, it'll be that, take away 3 lots of that. Now it's so easy, you can do another one. This one will be that, take away 3 lots of that.
1.5.
That's correct. Next one is done. 1, take away 3 nothings. Nothing, take away 3 quarters.
Negative 3 quarters.
Oh, well,
120, take away 3 37 and a halves.
Minus 120, what was it? 150.
120.
Is that just like something like that?
Why are we taking away?
There, 7 and a half. 120, take away 3 of those is 7 and a half. Okay. This gives us our optimal solution or not. Guys, can we listen, please? Shh. We need to decide whether this gives us our optimal solution or not. What do we do to identify whether it's optimal or not? Rob, can you read out what was our optimality condition?
If the objective row of a tableau has 0 entries in the basic columns.
Stop there a minute. Basic columns at the moment are these 2 here. But don't worry about this one, it's these 2 here. And they do have 0 entries there. So it meets that bit. Keep talking.
And no negative entries in the non-basic column.
And no negative entries, but it has got a negative entry, so it is not optimal. So we need a new tableau. So we start to draw out again a new tableau. And how do we identify our pivot? What's the first thing we do to identify our pivot? Can somebody tell me?
I just have a question for that.
Okay.
In the optimality condition, why does it say if the objective... Oh, if the objective row has 0 in the basic column.
Okay. So, question to you all. Jess, question specifically to you actually. How do we find the pivot?
So the pivotal row would be the X ones, that's what we...
The pivotal column, yeah. The pivotal column is the most negative value here, so that is the pivotal column.
Yeah.
Okay?
The pivotal row we calculated by doing
What have I got to work out now over here?
the value.
The theta values. Okay?
Which is the value of the end of the row divided by the pivotal column.
Yeah. Yeah, that's right. I now work out theta values over here. I work out 7.5 divided by 1.5. 7.5 divided by 1.5. Can anybody tell me what 7.5 divided by 1.5 is?
3, 4.5, 6, 5.
5 is correct. So theta there is 5. That was the value column number divided by the pivot column number on that row. Will Taylor, how do I work out the theta value for this row?
37.5 divided by 1.5.
It's that one divided by what's in my arrowed column,
Oh yeah, half.
the half. Okay? Without even working that out, it's very clear that the minimum of those 2 is going to be this one here. Okay, because that one's going to be double 37.5. That one's going to be 75. So the minimum theta value is this one here. So that identifies for me my pivotal row. So now I have my pivotal column and my pivotal row, I can circle my pivot. And my pivot is that 1.5. I've identified my pivot. We could do, but it's a negative thing over here. So because I'll be dividing by a negative, I don't bother doing it. You only do it for positive values. So now I've identified my pivot, what do I do next?
Divide the row by...
Not yet. I'm not dividing yet. I just write something down. What do I write down when I've identified my pivot? A 1. My pivot is a 1. And what else do I do immediately then?
Or maybe I 0.
Yeah, make the others in that column 0. Okay? Now, next thing you do is to work out the other values in this column here, in this row. The row with the 1 in it, you work out those values. So what I'm going to do now is work out my new row 2. My new row 2, R2 star.
Oh, hang on. What was the pivotal one on the other? What was the pivot value on the other table?
On my first table, the very first tableau,
3 over 2. No.
you're going back to the very...
On the table we just did.
Here was 7.5 divided by 1.5, which gave us a 5, my theta value. And over here, 37.5 divided by a half gave me 75. Those are my theta values. Is that what you're asking about, Megan?
No, what the pivot one was.
The pivot one appeared down here. Whereas I created this second tableau, my pivot was down here.
No, I mean, why is 3 over 2 1.5 the pivot thingy?
Now, I'm just going to stop recording. My pivot here is my pivotal column sort of thing. It made this 1 here. I've got to work out my new row 2. It was a 1.5. It's now a 1. What did I divide 1.5 by to make it into 1? 1.5. So my new row 2 is equal to my old row 2 divided by 1.5. My new row 2 is my old row 2 divided by 1.5.
When you say old, you mean like the most recent one?
Yes, the most recent one. Yeah, the previous one, if you like. The previous one, yes. So I've got to do that for everything in this row. Every entry in this row, I need to divide by 1.5. So, first off, I will start with Rob. Rob, what is 0 divided by 1.5?
Go with 0.
That's good. 0 divided by 1.5 here will also be 0. Seth, what is 1 divided by 1.5? So sum is 1 divided by 1 over half, and that's the same as 3 over 2. Dividing fractions, keep, change, flip. 2 over 3, yeah, 2/3. Here, it's minus 3/4 divided by 1.5. Minus a half is correct. This is where you use a calculator, or your brain probably explodes when you do too many of these. And if you do this on a calculator, can you do each sum twice on the calculator in the exam and check you get the same answer, just so you're not typing the wrong numbers in? Over here, 7.5 divided by 1.5. 5. We've now finished new row 2. So we go and do new row 1.
Right, the lesson is almost over.
So, new row 1, what we're going to have to do is decide what we do to this minus 4 to make it a 0. You ask yourselves, can we watch please? We will finish on this bit. Seth? How many of these do we add or take to that to make a 0? Yeah. So my new row 1 is equal to my old row 1 plus 4 new row 2. Okay? My new row 1 is my old row 1 plus 4 new row 2. And at that point, we're going to call it a day. This is where we got to last lesson. This is our previous tableau up here, and we've already started changing into our next tableau, and at the end of last time we were in this position here. We had identified our pivotal column, we put a 1 in here in our pivotal row, and we had noughts in the other ones. So, Adam, what was in this position in our previous tableau?
Is that the one above?
Yeah, -4. Okay, how many of those do I add to -4 to get 0? 4. That is why we've already written down over here, the new row 1 is the old row 1 plus 4 new row 2s. So the little star means it's new. So row 1 in the new tableau is row 1 in the old tableau plus 4 lots of row 2 from the new tableau. So now we go and finish off or complete row 1. So in here it's old row 1, which is 1, plus 4 lots of 0. What is 1 plus 4 lots of 0? 1. So that gives that. Here it is what used to be in this position, which is that 0, plus 4 lots of 0. 0 plus 4 lots of 0 is 0. Next position will be 0 plus 4 lots of 2/3. And it's easier to work in top heavy fractions. 8/3. This position, it would be 3 plus 4 lots of -1/2. Is 1. And in this position, 450 plus 4 lots of 5. 470. Okay. So that is that top row in this tableau completed. Sorry? None of it's negative, which may be interesting for later on. Now working down here, we need to say, okay, in this position there used to be a half. How many of these do I need to add to a half to make it into 0? How many 1s do I need to add to a half to make it 0? -1/2. So my new row 3 will be equal to my old row 3 take away a half of my new row 2. It's always multiples of the row that went in first. So my new row 3 is equal to my old row 3 take away half my new row 2. So down here it is 0 take away half of 0. Correct, 0. This position here, it used to be a 1. 1 take away half of 0. 1. This one here in the S column up here is a 0. 0 take away half of 2/3. -1/3 is correct. Okay, 0 take away half of that. In this position here in the T column, it's a 1/4 take away half of -1/4. 1/4 take away half of -1/4. Do it on a calculator if you're not sure, okay? 1/4 take away a half times by -1/2. Has anyone taken the advice of doing it on a calculator? I'll read the sum out. You type it into a calculator. 1/2. Can we type it in? Sorry, not half, 1/4. 1/4 minus a half times by -1/2. A half. Nobody got that right when they were just using their heads. That's not a criticism, it's just if you're doing these, use calculators and probably do the sum twice. Be careful with the signs. Finally over here it'll be 37.5 minus half of 5. 35, that's correct. Okay, so that is that new tableau completed. Well, yeah, what we need to know now is whether that is an optimal solution and what the solution is. The optimal condition, we had this last time, was if the objective row, which is the top row, has 0 entries in the basic variables, that's in the variables that really are things, in the x and y, when it does have zeros there, and there are no negative entries in the columns labelled by the other ones, there are no negative entries here, then the solution represented is optimal. So we have got an optimal solution. Now we need to interpret our table and see what it is. We want to know what x is, we want to know what y is, and we need to know what z is. To find out what x is, you find the x column where it should be all zeros apart from 1, 1, and you find where the 1 is, and you then go and read off the value at the end of that row, which is 5. So x is 5. To find what y is, you do the same thing. Find the y column, there should be all zeros apart from a 1, find the 1, and then go to the end of that row to read off the value. And the value of y is 35. So those are our two decision variables, and z was our profit, or whatever we're trying to maximise. So go to the z column, should be all zeros apart from 1, 1. Find the 1, go to the end of that column, read off the value, it's 470. So the question we started with, which you can see here at the top of the board, that was the question we started with. We have got an optimal solution to that is x is 5, y is 35, and z is 470. Is everybody clear and happy how we got that from that table? We have finished our first example. Example 2, the next one. First off, can anybody identify, first of all, what's the main difference between this example and the previous example we've done?
What was that?
Yeah, it's got a z, it's got a third decision variable. So if we were doing this graphically, we would have to draw a three-dimensional graph. You can't really draw them, you have to sort of build the thing. So we can't really do it any other way than this way. Okay? So, we've got two constraints. We've got our objective function, we've got the non-negativity ones as well. If you look back in your notes for example 1, what was the first thing we did last time? What was the first thing that we did? Okay, so what do we making equal, Jess? Making the
Inequalities.
yeah, making the constraints, inequalities here equal. So this one here will become, well, what will it become, Jess? How am I going to make this equal?
2x plus 3y plus 4z plus 2.
We generally use s for the first one and t for the second one, okay? So s, and I'm going to leave a gap actually there. I'm going to leave like a t column, although I'm not going to put anything in it, and that would equals 3. So Megan, can you do the same thing for the second constraint? What will that be?
6x plus 6y plus 2z plus t.
Yep, and that will equal 8. It's not a bad idea when you do this to actually write in here that in this bit here there are no s's, and in this bit here there are 0 t's. Because when you do it in a tableau form in a minute, you will need to enter those zeros in. So we dealt with the constraints and made those equalities, not inequalities. What else did we do right at the beginning before we even drew the tableau? There was something else we changed. Did something to the objective function. Yeah, put it equal to 0, that's right. We made it equal to 0 by shifting all of this stuff onto the other side. So Sam, how will I rewrite this objective function?
Just be minus 3. Which way, Jess? Oh, the top one.
The top one, yeah. I'm going to start with my p.
Yeah. Minus 8x.
Yeah, that's right. Minus 8x
Minus 9y.
minus 9y
Minus 5z.
minus 5z equals 0. That's right, okay? And bear in mind, I could put in there as well, at that point, that there are no s's and there are no t's. I could put that in there, because in a minute when I put it in a tableau form, they will appear there. So, I'm going to start my tableau. I'm going to have my first row in my tableau above this line. What do I usually write on the extreme left? What's the left-hand column usually? Yeah, it was this. It's whatever you're maximising and minimising. Sometimes it's Z. In this one, it's going to be P. Then what other column set am I going to need here for this question? X, Y, yep, yep, yep. Yeah, that's right. Excellent. Okay. So P, because that's what I'm trying to maximise. X, Y, Z, my decision variables. S and T, my slack variables. One for each constraint and value out of the end. Adam, can you tell me what entries I will put in my first row, reading left to right? The first thing, it will come from the objective function here. That's right. Yep. My next row will come from my first constraint, which is this one here.
Yeah.
Okay.
Oh, 0.
Yeah, because P's not there, it's a 0. That's right. Yep.
2.
Yep.
3. 4. 1. 0. 3.
That's right. Good. Rob, the next row will come from this constraint here. What will that one be?
0. 6. 6. 2. 0. 1. And 8.
That's right. Okay, so that's the initial tableau at this point. And if you try to interpret that at the moment, these two columns here with the noughts and the 1 that are telling you at the moment we're making 1 unit of S, which doesn't really exist anyway. We're making 8 units of T, which doesn't really exist anyway, and our profit is 0. That's sort of how you always start with something that doesn't really make much sense at all. Okay, so now we need to go and find what we do. How do we start off? And what do we do to start with? We've got to identify something first of all. Can we remember what's the first thing we do? Not yet. We look, first of all, we've got to try and identify first of all our pivotal column. How do we identify our pivotal column? It will have a 1 in it in the new one, but at the moment, how do I identify my pivotal column? It's something to do with the top row, the top number row. Most negative, yeah. The most negative value is in that column there. So that will become our pivotal column. Now I've identified my pivotal column, I need to find my pivotal row. So I've got to do some calculations. Can anybody remember what calculations I do now to find my pivotal rows? My pivotal row. This is where I do those theta values. Can you remember what they are? Well,
Is it the value at the end
yeah,
over the value in the pivotal column?
yeah. It's the value of the value divided by the value in the pivotal column. So here it's this 3 divided by that 3, so it's 1. Harriet, what will it be in the bottom row? What will theta value be here?
8.
Yeah, it'll be 8 divided by 6, which is 1.3 recurring. Then when we've got the two theta values, which one do we choose? The smallest one. Yeah, you choose the minimum. It's the minimum that is the one you choose, which means this row here is a pivotal column. It's a pivotal row. That's a pivotal column. They meet at our pivot, so 3 is our pivot. And now we're ready to start the new tableau. Tableau in this question. I've identified my pivot. Jess, now I've identified my pivot. What happens next? Can you remember?
No, it's 1.
Pivot is a 1.
Same with 9 and 6 is a 0.
Yeah, and everything else in that column is a 0. Yeah, the pivot becomes a 1. Everything else in that column becomes zeros. That's right. So, Jess, what did I do to that 3 to make it into a 1?
You added 4. No, you divided by 3.
Divided by 3. And you can only answer that question by saying you divided or times by something, yeah. So to get from that 3 to that 1, I've divided by 3. So this row now, my new row 2, which I'll call as row 2 star, my new row 2 is going to be 1/3 of my old row 2. Basically the old row 2 divided by 3. So I'm just going to go along my old row 2 and divide everything by 3. So 0 divided by 3 is 0. 2 divided by 3 is 2/3. 3 divided by 3 is 1. 4 divided by 3 is 4/3. 1 divided by 3 is 1/3. 0 divided by 3 is 0. 3 divided by 3 is 1. Sam, if you could help me with the top row. There was a -9 there. There is now a 0 here. How many of those did I add to that to make it that? 9, yes. So my new row 1 equals my old row 1 plus 9 new row 2s. My old row, sorry, that's that again. My new row 1 is my old row 1 plus 9 new row 2s. Right, I don't mind who shouts the answers out. So here it's going to be 1 plus 9 zeros. Here it's going to be -8 plus 9 2/3. This is what I think. Go for your calculator. What have we got? -2 is correct. The next one is done. Here it's going to be -5 plus 9 4/3. 7 is correct. 0 plus 9/3. 3 is correct. 0 plus no thirds. 0 plus 9 ones. And we have that top row done. Okay. Rob, the bottom row, how many of those, Rob, do I add to that to make it into that?
-6.
-6 of them, yeah. So, Rob, can you tell me what am I going to write down here for my new row 3?
New row 3 equals old row 3
Yep,
minus
yep,
6 of new row 2.
yeah, that's exactly right, good. New row 3 is old row 3 minus 6 new row 2. Again, I don't mind who shouts the answers out here. The first one will be 0, take away 6 zeros. The next one will be 6, take away 6 lots of 2/3. 2 is correct, whoever said the 2. The next one is done. Then it's 2, take away 6 4/3. Is correct, thank you, Harriet. 0, take away 6/3. -2. 1, take away 6 zeros. 1. And 8, take away 6 ones. 2. Okay? And there we've finished that next tableau. So I'm just going to shoot the other one off the screen a minute. So we're just looking at this one. When you finish a tableau, you're checking for its optimality or not. So you're looking to see whether the x's and the y columns have just got all noughts and a 1 in it. Well, this y one has, but the x one hasn't. And there's a negative one. That's not optimal. We're going to have to do it again to get another tableau. So what we need to do at this point is to draw out another tableau for the next stage. Decide what to do first of all. We've been through this once today. What's the first thing you do when you're starting a new tableau? You have to identify the pivot. First off, you identify the pivotal column. Seth, how do I identify the pivotal column first of all? Most negative one in the top row, which means it's the x. What do I do now I've identified the pivotal column? Anybody? Find theta. Yeah, okay. So I need to find theta over here. Theta will be 1 divided by 2/3, which is 1.5 or 1.5. Here, theta will be 2 divided by 2, which is 1. What is the minimum of either of those two? 1. 1 is smaller than 1.5. That's my minimum. There. So this is my pivotal row. Where my pivotal row and my pivotal column meet, that is my pivot. Rob, what do I do at this point when I've identified my pivot?
You put the same point in the next tableau to be 1.
Yep. And what else can I do immediately?
Put the other 2 in that same column as 0.
Yeah, everything else in that column to be zeros. Okay. And Rob, what have I done? And you're only allowed to answer using timesing or dividing. What have I done to that number to make it this number?
Divided it by 2.
Yeah, divided it by 2. So my new row 3 is equal to my old row 3 divided by 2. Megan, choose another row and take us through what we do. Going for row 1 or row 2?
Row 1.
Okay. There was a -2 in there. There's now a 0 in there. And I've got to use this 1 down here.
Old row 1 plus... No. Yeah, plus 2 row 3.
Yeah, 2 new row 3. That's right. So new row 1. Okay, new row 1 is old row 1 plus 2 lots of new row 3. So the first entry is going to be 1 plus 2 lots of 0. And skipping to the y column, it's going to be 0 plus 2 lots of 0. 7 plus 2 lots of -3. 3 plus 2 lots of -1. And we can just keep going along here. I'm not going to talk through everything else here. I want you to just get that next row done yourselves. Okay? For this one, should be the new row 2 is old row 2, take away 2/3 of new row 3. Second row, the value's going across here, and what we need to do now is to work out whether it's an optimal solution or whether we need to do it again. What are your opinions? Is this an optimal solution or do we need to do it again?
It looks pretty optimal.
Why does it look pretty optimal, Rob?
Because x and y, hold on. Did z need to have only 0s and 1s as well? Okay, well, in that case, x and y only have 0s and 1s.
X and y only have 0s and 1s.
And you don't want any negative values on the top.
No negatives at the top, yeah, so it is going to be optimal. Now what we need to do is to interpret the solution. We need to know what the value of x, y, z and p are. Will, from this, what is the value of x?
is it 1?
Yeah, because we come to our X column and we find the only 1 in it. So that's not the value. We shoot over to the value column. It's 1 because of this 1 over here. Sam, what is the value of Y?
A third.
Yes, right. We find the Y column. There's the 1. We go across. It's 1/3. Z. What can anybody say about Z?
No, you can't find it.
So Z does not feature in our solution. Z will be 0. If Z, which is a real variable, it's a real decision variable, has not got noughts and 1, it just doesn't feature in our solution. So Z, we won't make any Z if it's a manufacturing process.
How do you know if you do it again?
Because we know this is optimal because it met the optimality conditions. We know this is an optimal solution.
No matter how many variables go out, so
No.
we get
Yes. Yeah. Okay. But there are no negatives up here. It has met the optimality. P, the value of P, go across from that 1 is 11. So we've just solved one with 3 decision variables, which we haven't looked at before. Couldn't do it graphically. Use the simplex method, then we've got our answer.